All right, in 950 notes, we're going to look at acid base strength and pH. You will need a scientific calculator, one that has the log button on it. Okay, so overview, just qualitatively, weak versus strong, what does that mean? Well, strength is based on the degree to which an acid or base forms ions. So it has nothing to do with molarity per se, but rather like the nature of the acid or base. Some acids or bases will dissociate more than others. So a strong acid or base is one that ionizes or dissociates completely in an aqueous solution. For example, if they show this like equation up here, if you notice HA, which is your original acid, you put it in water, then what happens is it attaches to your hydronium ion, and then it creates its conjugate base. Down here, like HA, that original acid is completely, there's nowhere you see any of it. So like it was all broken apart or all dissociated. So you make lots and lots of ions, and then it's considered a strong acid or base. So lots of H pluses will give you a very strong acid. Lots of OH minuses will give you a strong base. The more polar the substance, the more it will dissociate or ionize, and the stronger it will be. So 100% ionization or dissociation um, results in a strong acid or base, or which are both strong electrolytes. So, for example, hydrochloric acid, nitric acid, sulfuric acids are all acids that will completely dissociate, and so they are considered strong acids. Any hydroxide, sodium, lithium, calcium, for example, will do the same thing. So they're going to create lots of ions, and so they are going to be considered very strong. Strength of bat is based on the degree to which an acid or base forms ions in water. So a weak acid is only going to release a few hydrogen ions. It's going to release some, and so when you test it, with a conductivity tester, you're going to see it light up. But if it's like the light bulb one where you have a degree of brightness, it's going to be pretty dim. So you're going to have less than 100% ionization or dissociation. So for example, if you look at your original acid, has this symbol here, you'll see that they're still remaining even after they are put in solution. So this is acetic acid, for example, phosphoric acid, carbonic acid. These are all considered weak acids. They don't produce a lot of H pluses or hydronium ions. Weak bases only produce or release a few hydroxide ions in aqueous solution. So same, concept as an acid, except your original base is going to be it's going to be intact when it's weak. So you're not going to produce a lot of OH minuses. Qualitatively, we call these weak versus strong. Quantitatively, we are going to calculate them as pH and pOH. So, by the way, for example, some different bases, ammonia is a weak base, so is aluminum and iron hydroxides. Okay, pH is where we're going to spend most of the time here to do some calculations. You will need a calculator in a little bit here. First of all, just to remind you what pH means, it's like the power of hydrogen. So hydrogen, lots of hydrogens will release, the more hydrogens we have, we're going to have a lower pH. And so this is very acidic down here. Our scale goes between 0 and 14. So 0 is our minimum, 14 is our maximum. This is going to be a very strong base down here. This is a very strong acid. Acidic goes until below 7, and then 7 exactly is considered neutral. Pure water is 7, and then above 7 is going to be considered basic or alkaline. So here are some common substances: stomach acid, strong acid, hydrochloric acid. Vinegar is going to be a weaker acid. acetic acid, for example. Lemons, tomatoes are also some different examples. Coffee is still acidic, but it's a weaker acid because we're getting closer to the end of the range. Milk is close to neutral. It's 6 point something. And then when we get to the other side of the range or scale, where we have baking soda, blood, those are close, but they're a little bit alkaline or basic. Stomach tablets, soap, ammonia, bleach, we're getting pretty strong. And in high in pH, drain cleaner is very, very strong base at the end there. pH can be measured by chemical indicators. So we have lots of different chemical indicators. We have things like papers, we have liquids. We also can use pH meters. Those will give you more accurate. A lot of these are just going to give you some colors. So you can just match up to a known range and figure out what pH you have. If you have a pool or a hot tub, then you're probably, familiar with this to see what pH you have currently and see if you have to, add any chemicals. So again, pH is down here at the 0 to below 7 mark. That's all considered acidic. High pHs greater than 7 are going to be alkaline or basic. Neutral is only at, purely neutral is 7 right here. As far as our ions, we're talking about hydronium or hydrogen ions, lots of them are going to be down at the end here. So the more I have, the lower my pH, the stronger my acid. If I go to the right, I'm going to get fewer H's or hydroniums and more OH minuses. So down here would be pure OH minus, not a lot, or maybe no, if you're at a 14, no H pluses. So that's the absence of the hydroxide. So the more H pluses we have, or hydroniums, because we could use those interchangeably, that's going to be lower pH, which is stronger acid. And then the more OH minuses I have, the higher the pH. So it's going to get as stronger as a base. So the opposite sides, strong base down here, strong acid down here. And as I go, left to right, I'm going to decrease my H pluses, but I'm going to increase my OH minuses. And that would be the opposite true going from the other side. So we're going to use the log button to take these concentrations and create them, or convert them rather, into pHs and sometimes POH, which is the counterpart. The reason we use that is it's just a lot easier to deal with than these tiny numbers. You're going to have a lot of time negative exponents. So it's just a way to have a little bit more of a practical way to express our amount of acid. Okay, so if you know the pH, you can calculate the concentration of hydronium ion, or vice versa. If you know the hydronium concentration, you can calculate the pH. These two are important formulas. You do not need to memorize them, but you will need to know how to put them in your calculator. So I will show you how to do that in a second. If you are given, or want to find pH rather, you're going to hit negative sign, log, and then you're going to type in your concentration. It should give you something between 0 and 14. Now, if I want to go the opposite way, I'm going to hit inverse log, which is 10 to the negative. You're going to hit a negative sign and then pH. Again, I'll go over this in a second. So, for example, if we find the pH of a solution with 0.01 molar hydronium concentration, and by the way, these brackets mean concentration. So whatever's inside, it's the concentration of that. What you're going to do is you're going to hit the negative sign, log, and then you're going to type in 0.01. If you try that right now on your calculator, you should get a 2. 2 is acidic, so you would identify that as acidic. You do the same thing if you're going to find the POH if you're given the hydroxide concentration. So H plus and pH go together, OH minus and POH go together. So this is talking about POH. Then we're talking about the hydroxide ions that are in your solution. The greater the OH minus, the lower the POH. So as pH goes up, POH goes down, and vice versa. The maximum is 14. So when you are calculating, like say they give you pH and they want to know POH, all you're going to do is subtract it from 14. That's an easy one. Or vice versa. They give you POH and they want pH. All right, if you know the POH, you can calculate the concentration of hydroxide. Again, this is the same calculation as the pH, except these two go together. So OH minus goes together with POH. And H plus or hydronium, I should put concentration. Concentration goes with pH. All right, so same thing. What if they gave you they want the concentration of hydroxide ions, but they give you the pH? Well, subtract it first to get the pOH. The pOH would be 6, since that's the difference between 14 and 8. And then you would hit inverse log of -8. I'm sorry, -6. Sorry. And then you would get 1 times 10 to the -6. All right, so this is, I just have a picture of like what is a typical graphing or scientific calculator that you may be using. So even if yours doesn't look exactly like this, the buttons most likely are in the same positions. If they're not and you are unsure, let me know and I will show you how to use your particular calculator. But say I want to find pH from H plus or POH from OH minus. First of all, I'm going to hit the negative sign down here. Then I'm going to hit the log and then whatever concentration they give me. So say they give me like 4.2 times 10 to the -5. Hopefully that's something you know how to type in, but you would hit negative sign, log, and then whatever this concentration. So for example, what this concentration would be. I'm going to plug this in my calculator. Go ahead and you can plug it in yours and see if you get the same answer. So I got about 4.4 as my pH. This was just a random example here. 4.4 if I round it. So say this was H plus concentration or hydronium, either or. Negative log of this would give me that. All right, I would do the same thing if they gave me hydroxide concentration, and I want POH, same sequence of buttons. Now, if I want to go the opposite way, say I want to find H plus from pH or OH minus from POH, I'm going to hit most likely second function log button, which will give you 10 to the x. Then you're going to hit the negative sign and then whatever they're giving you. So say, for example, my pH is 6.5 and I want to know what is the H plus concentration. So I'm going to do this on my calculator. You can go ahead and try on yours, see if you get the same answer. So I'm going to hit second function log, negative sign, 6.5, and I get a pretty small number, which is expected. I put mine in scientific notation. If I round it to 2 sig figs, it's 3.2 E -7. And when you're doing concentration, you should use molarity, so M, capital M after it. All right, I'm going to do a few of these. You can stop the video if you get it and you want to try your own, or if you need more practice or instruction, I'll do a few of these rows. Okay, so if I was given pH as 3.78, I could automatically answer a few questions. One, I can do this one's pretty easily, the POH. So take 14 minus 3.78, and I get 10.22. Now I know from my definition that pH less than 7 is an acid, so I can answer that one. Now what I can do is I can do I think I just put it in the wrong spot. Sorry, this is 10.22. So let me erase that. Okay, so what I can do now is I can take, if I'm given pH and I want to figure out hydronium, I'm going to hit second function log negative 3.78. And I get, I have to put mine in scientific, 1.7 or 1.66 E negative 4 molar. Now I'm going to do the same thing with this. Same thing. So second function negative 10.22. And I'm going to get 6.03 E negative 11 molar. So I have, if remember, like negative 4 is going to be a lot bigger than negative 11. So I have a lot of more hydronium ions, and that's why I have a lower pH. All right, this time, this second row, they're giving me hydronium, and I got to figure out the rest. So what I can do is I can figure out pH from this by hitting negative log and then 3.89 negative 4, E negative 4, which I get 3.41. All right, I know that's an acid. I can answer that one. Now I can take 14 minus 3.41 to find the POH, which is 10.59. And then to figure out the OH minus, second function log negative 10.59. And I get 2.57 E negative 11 molar. These happen to be similar concentrations, these first two rows. All right, let's try maybe one or two more rows. Okay, if I am given 5.19, I can figure out the pH. 14 minus 5.19 is 8.81. My knowledge is greater than 7. It's a base. So now what I can do is figure out the concentration. So from here to here, second function log negative 8.81. And I get 1.55 E negative 9 molar. Do the same thing for this. Second function log negative 5.19. And I get 6.46 E negative 6 molar. All right, let me try one more. All right, so the last row or last one we'll do here. This row gives me the hydroxide concentration. What I can do is I can go to POH. So negative log 4.88 E negative 6, which I get 5.31. Remember, these go together. So just to emphasize, these go together, these go together. Okay. Now, if I know this, I can take that, subtract it from 14 to get my pH, which is 8.69. That's a base. Now I can do one more. I can figure out the hydronium concentration from that. Inverse log negative 8.69. And that's 2.0 4e negative 9. E negative 9. All right, hopefully that helps your practice. The second page is a lot like this table setup.